All right, now we're doing the kinematics section, which is basically this stuff. The first thing we'll do is what's the maximum speed? Wait, that's not the first problem. The first problem is this. Problem what's the particle's initial velocity? So what you have to do is S equal 20t plus 4t squared minus 3t cubic. You take a ds dt, which equals 20 plus 8t minus 9t squared, and then you put t equals 0 over here. Now, fun fact, you don't have to write that down. You can use your calculator to do the derivative for you because you're looking for a point and not doing basically take your computer, your it's a basic computer, do a second derivative like this, and with that you can put in your polynomial. Let me really quickly show you that I can do that. 20tx plus 4x squared minus 3x to the cube at 0. You can get this over here that is 20. Although it does have some error because it is definitely doing what they call integration by those weird integration they do with the computer, like they don't really properly do integral. They use a method of differencing or something that's not proper, so there's a little error in your calculator. So yeah, either way, we know by doing this is 20 by just looking at it and just doing it. I mean, this question you can just do it. There's no point for you to not just do it. Okay. Anyway, next question. What is the acceleration at the time t equals 0? So again, we can do it this way, and for argument's sake, let's just say I did it this way. 3 parentheses, this equals 20 plus 8t squared, 8t, minus 9t squared. And then you have equal to 20 plus 8. And then that's basically, and then there's minus 18t, but we don't care about that. Wait a second. Did I make a mistake here? Oh, this is 0. Sorry, this is 0. 8. Apologies. Because derivative of that is d. Problem 2 is D. Anyways, another thing I will mention is let's look at the calculator. Can I do a double derivative over here is the real question. Can I do a derivative and a derivative? I don't think so. So there's a limit to it. A double derivative you can't do by a calculator, I don't think. Maximum speed reach of the particle. All right, now this is doing a derivative and doing a derivative, and we have done that, and I deleted it all, so that's fun. Oh, by the way, we're finally in the dynamics section. Weehoo. So basically we're just doing derivative and a derivative, so nothing really special. So very easy, very, very elementary particle ideas, right? Particles. It's actually not impractically easy, it's just you can do it easy. It's probably the best way to explain it. Because I don't want to call something trivially easy because people that's only because you have, and that's not true. Nothing is trivially easy, basically. And I'm living here because I'm just saying random stuff now. Okay, and then this one is 8 minus 18t. Okay, now I'm going to use this calculate function to find the zeros on the polysolve. Use polysolve, second polysolve with 1. And then I'm going to do negative 9, delete the rest of this. So this is actually quite useful. Clear 8, and then 20, and solve. So equals 0. So I get by this t equal negative 10 over 9, and t equal 2. I hope I'm right. You can double check my math. Um, hmm, yeah, I think I'm right. Um, so oh wait. I'm looking for the max over here. Why am I doing that? This is asking for the maximum speed reach a particle. So this derivative, you just do 8 minus 18t equals 0. So that means 18t equal negative 8 positive. So t equal 8 over 18. So division, wow. This question becomes division 8 over 18. And that is about 0.44 seconds. Now we plug it back into here. So 20 plus 8 multiplied by 0.0444 minus 9 multiplied by 0.0 squared. And that's 21.7. So that's A. That is A. So I'm just going to assume I got correct and move on. Choose an equation that best represents the rigid body of a particle under constant acceleration. Okay, so choose this equation that is best represents a rigid body particle under constant acceleration. Okay, so why would you need a time acceleration change? We know it's a equal, I mean 9.81 makes sense, but why is the rest there? Okay, that doesn't make any sense. Um, oh, this actually does make sense. D makes sense. So I'm going to choose probably. Huh. No, tangential also can be wrong. So what does that mean? That's probably not correct because V is still tangential. You can have a elliptical. I only know this because I did orbital mechanics. So we know that this is wrong and this is wrong. So it must be B. And is there a way to like showcase that even more? One of these equations? There probably is. Probably one of this one. Because this is AO. I'm just not seeing it right now. But V equal AT minus AOT plus VO, right? Ah, here it is. This is a constant. So this is shown. Okay, yeah, this works. V works. Yeah. A roller coaster train climbs a hill with a constant gradient over a 10 second period. It's just 10 seconds at this point. The acceleration is constant at zero point 0.4 meters per second square, and the average velocity of the train is 40 kilograms divided by hours. Okay. Find the final velocity. Okay, we can do that. First thing we note is we have average velocity. So, well, uh, 40 kilograms per hour, meters, multiplied by 1,000 divided by 3600 equals what? I need to get my calculator. For multiplied by the 1,000 divided by 3600, that equals 11.1 meters per second. With that said, um, we can get distance because it's 10 seconds, right? So it's 11 meters. Now we're trying to find the final velocity, not the average velocity. With that being said, a roller coaster climbs a hill with a constant gradient over 10 seconds. So the acceleration equals zero point 0.4 and it's constant. What can I do with this knowledge? Well, I know that S equal SO. Does it say that the initial condition is zero? I'm not sure. No. We have to figure that out. But we can do this. Yeah, we can definitely do that. And we know the final condition, which is on 11. 11. This is 0. Okay. We know this is 10 seconds. Huh. So we can find VO. Yeah. I mean, I don't see any reason why not. Unless you guys see it. I'm just going to plug into my calculator now because I think this should get VO. For initial, basically, if you didn't get my drift. Maybe I need a new mic. Yeah, whatever. You didn't come here to hear my voice. And I'm too lazy to buy a mic. 9.1 meters per second. Now, with that said, we have V final equal VO plus AT. Now we know that V final equal 9.1 plus 0 0.4, 10. So 9.1 plus 0 0.4 multiplied by 10. I get 13.1. That's C. You know, I just realized having an earphone listening to your own voice is weird. Anyway, projectile is fired from a cannon, all right, with an initial velocity of 1,000 meters per second and at an angle of 30 degrees from the horizontal. What is the distance from the cannon? Will the projectile strike the ground if the point of impact is 1,500 meters below the point of release? Okay, this is just a regular question. So you figuring out X, the craziest part is just finding the right equation. So S final equal SO plus V initial T plus minus 4.9 T squared. Now we know initial conditions, which is 150 plus 1,000, right? And then it's going to be sine theta, which is 30, T minus 4.9 T squared equals 0. And I've told you before, in the calculator, there's a polynomial function that allows you to see it easier. Now, do I recommend you use it? Yeah, 100%. Yeah, we're in 2026. We don't do algebra by hand anymore. That is a long time ago. That's when you're in high school, even in elementary school, maybe even. I don't know anymore. With the recent math skills of I don't know, it's really weird. I don't know. Because I've seen that they're saying that the average ASCII has gotten down, which could be possible. I believe that because I've seen these old people can do algebra like that. There's no question. But we are going to rely on calculators because they're more accurate than any human. Uh, so here's what my calculator got. Beautiful. So we know this is wrong. This is negative. So it must be 104. So now we can use this on the x direction. We know the x direction now. We know the t now. So we can erase all this. And then we can do the same thing again, but the final's unknown. This is a question mark, and that's actually gonna give you the answer. And then we have 0 for this one. We have 1000 cosine 30 t, which is this, a minus 4.9 parentheses t squared, which is this. So with that said, let me just get the full like 104.9574501 just to get the t right. Seconds. If you want to be more in my high school, they used to care so much about the units in between the stat. I was like, yeah, AP exams are weird. Never liked them. Yeah. Also, the SAT was weird to be fair. No one liked them either. All right, multiply by 104 square. Okay. Maybe I need to add more digits because yeah, this is something, but I think more digits would have been helpful. But yeah. Oh wait, I'm stupid. Delete this. That's why. I was wondering why none of the answers. Remember, this is only for y direction. So delete all that. Oof. Mistakes have been made. Well, in this case, like 20 billion mistakes. Okay, so is I thought I deleted though, but it's not deleting. Clear all that and let me just do it myself again. Cosine 30 multiplied by 104 is a 9 with a lot of zeros. I'm assuming this error is from me not putting enough digits. Let's put a little bit more digits here. Yeah, if I put 104.95 instead of 104, you get that. Yeah, I just put too little digit. But again, these answers are so far apart that it's fine. If it was closer together, then you had to worry, but you're fine here. Refer to the particle in which the position is defined by this. Uh, okay, yeah. What is the magnitude of particle velocity at 4 radians per second? So again, this is st, which is equal to 2 sine t plus 4 cosine t. Then you take a derivative of that, which is equal to, you know, actually, yeah. And then you do this as equal to 4 radians. And you have to do the derivative of that, which is, let's just do it. 2 cosine t minus 4 sine t. I was going to make the calculator do it, but I'm not that much of a bum. And I say that while I'm not actually typing this in, and I'm just using the calculator function with a derivative, even though I solved it by hand. I'd rather just let the calculator do a derivative again. So if you don't know, the TI-36X Pro has a derivative function that only works for a point. So as long as you know a point, you can actually get use out of this damn calculator. Um, why is it not working? Because I didn't put a point in there. There's still a syntax error. It's because I put one too many parentheses. All right, with the calculator, I get negative 3.345. Okay, I'm doing it by hand, apparently. Let me just do it by hand because obviously, obviously there, I forgot that's numeric, so there's a small error in it. So I'm not sure if it's correct. Yeah, it's not. Okay. Um, I get, wait, let me look at the original question. There's a mistake on here. Okay. Not your fault, not my fault. There's a mistake on here. There's supposed to be I. Why do you do this to me? Bold, underline, plus, plus, plus. Now it makes sense. Good God. Okay. That makes sense now. Okay. Yeah. Let's erase this and redo this because obviously the original question intended for I and J to be in there. And let me just, because it's going to be using the other one, let me just fix it for the other one. Yeah, because that would be a problem. Yeah. I was getting insane numbers. It was like, that's not even close. Like negative 4.3. Like, what are you doing? So this makes more sense. T equal 2 sine T I plus 4 cosine T J. By the way, look at the description for all these questions. Cosine I equal d s dt, and then plus 4, which is minus sine of t, j at radian is 4. So we can do 2 cosine 4 parentheses equal negative 1.307 uh, to 8, and then minus 4 sine 4 parentheses, which is 3.072 uh, I j and plus. So parentheses, the first one, parentheses squared plus second one, and we get 3.2974, which means a C. All right, a C. Okay, we're good. That's the second one. What's the magnitude of particles acceleration at pi? Just bring back the original one. And you can take a derivative of that, d squared s dt, and then we can do 2 negative sine equal theta, not theta, time in this case, t I, and then it's negative 4 cosine tj. And fun fact, if you do cosine and sine wrong, it doesn't matter because they use magnitude. So it's just testing your derivative knowledge at this point. Is parentheses. This is actually 0. So 4 cosine pi parentheses equal negative 4. So it's d. So this is d. So we just insert d over here. Move on. Okay. Let's look at this question now. Why is it not erasing? Question 3, 4. For a reciprocating pump shown, the radius of the crank is r equals 0.3, and the rotation is n equal 350 RPM, which means angle the revolution per minute, I believe. What is the tangent velocity at point A on the crank corresponding to angle 0.30? So this is Vt equal r omega, clearly. So with that said, what we're solving for is just VT at this point. I don't think this is a complicated, you need to do a lot of things. Um, because the radius is the same, 0.3. With the omega, it shouldn't really matter what the force is. The force of the tangential must be constant. And it's in place, so it must be constant. So what I'm going to do is 0.3 multiplied by 350 RPM. RPM revolutions per minute. So one revolution is 2 pi. And then multiply by 1 minute, which is 66 seconds, which equals what? Get your calculator out. You can do 2 pi divided by 60 equals like pi over 30. So 0.3 multiplied by division, 350, multiplied by pi divided by 30, which is about 10.9 9. So it's D, round up because it's near there. So it's that. Yeah, this I don't know what this angle is for, 35 degrees, why are you even there? But this is a omega r question. Fun fact, wait, here's a trick. If you get something a circle like that, and you have like a tangent, and it tells you that it's spinning, it's most likely a omega r question. Unless we're doing some weird frame stuff with different limbs, you can assume this. Yeah, most of the time. Looks like. I'm not sure. That's my guess. A golfer on the level ground at the edge of a 50-meter wide pool attempts to drive a golf ball across the pond, hitting the ball so that it travels initially at 25 meters per second. The ball travels, oh yeah, horizontal plane. How far will the ball travel? And does it clear the pond? So it's a 50-meter pond, right? You start with a 45-degree, right? You have a 25 meter per second, right? Sounds like a classic. Where would it hit? So with that said, let's plug and chug. Because we all know what equation we had to plug in here, which is 4.9 t square, our beautiful t square, minus, no, plus, this is minus, 25 cosine, sine, no, sine. Sometimes you know you're making a mistake, but you still make a mistake. Anyway, sine Uh, my tablet sometimes run funny. Sine. It's not writing anymore. Sine 45. Okay, that's good. And then it's t. Okay, plus what was it again? 0 equals 0. Now I just realized my calculator's in radians, which is changed to degrees here. Uh, on the test before doing a question, probably check if there's an angle, if it's in a degree or radian form. If it's radians, it changes degrees when it needs to be degrees, and if it's degrees, changes radians. The biggest mistake you can make. It is actually number one, I think, in terms of people making mistakes because of that. Because I know it's for me. So I get t equals 0. And then t equal 3.67687. I use a calculator to find root function in my TI-838X Pro, which is the scientific calculator, which is allowed on the test. Okay, so we have this. Now we do 25 cosine 45t to get x final. So 25 cosine 45 multiply by 3.60787, which equals 63. Yeah, so it's D. Okay, so I see a ball. So I immediately think V equal omega R. It probably is in there. It's probably going to be used. All right, rigid link AB is 12 meters long. It rotates counterclockwise and about the point A at 12 RPMs or revolution per minute. So this is 12 RPM. A thin disc with a radius of 1.75 is pinned at the center of the link B. The disc rotates counterclockwise 60 RPM. With respect to point B, what's the maximum tangential velocity seen by any point on the disk? Fair enough. There's two omegas. So here's what I'm thinking. So this is clearly a relative question, right? So we first need to figure out V tangential at B over A. Um, so where do you think it is a question. Now here's the thing. It's obviously going to be on here. Secondly, this is also going to add to the velocity or subtract to the velocity. And in this case, it looks like subtract or is it counterclockwise, right? It rotates counterclockwise. So it rotates this way. First of all, I don't know why this drawing is so awful. Yeah. And it also counterclockwise. So what we should do, V equal 60. Uh, to change it to that um revolution. Is it in minutes or seconds? I think it's still in meters. Okay, so I need to change 60. 60 multiply by 2 pi over 60 should do the trick. So 2 pi over 60 multiplied by 1.75. And then we have this. We have V equal, what is it? I saw it earlier. 12. 2 pi over 60. The question is, where's the moment arm? What is the moment arm? What it is? We are going to say, I think it's 12 plus 1.75. That's probably what they're looking for, I think. All right. Yeah. Yeah. And now you just add them together. You just do V1 plus V2. So V1 plus V2, you think about it, you're going this way, you're going this way. This velocity plus that velocity equals greater this velocity. So it only works if you're looking at locally. If you look at it apart, it becomes a little problematic, and I'm not dealing with that shit. Luckily, you're not dealing with that shit too. So that's vibrations too. No, not dealing with that. But you want to deal with weird Hamiltonian shenanigans? Go ahead. Um, actually, technically, it's not that bad. I'll be honest. Um, 12 plus 1.75 parentheses divided by nothing. I don't know why I decided to divide. Okay, I got 28.27, so I'm pretty sure it's C. Okay, we're just gonna clarify. Oh, where am I? C. Okay. So the answer I got was 28.274 over here. Okay, great. But in fact, some of these questions I did multiple times, many times to get the right answer. All right, which is good practice for me. A particle has a tangent acceleration of at represented by an equilibrium given. When it moves around a point in a curve with an instantaneous radius of 1 meter, what is the instantaneous angular velocity in radians per second of the particle? Just take an integral and do it. What is so hard about this? Is the question now. Um, is it a double integral situation because we don't know r? Oh, no, it gives you instantaneous at 1 meter. Um, there must be something hard about this. I don't know. Let me just do the integral. At equal Vt, and then Vt divided by R equal omega, which is Vt over 1. Read it. Oh, reading is hard. Ah, yes, reading is hard. Always. Reading comprehension, that is always hard. I know. Anyways, T, 2, right? Minus cosine T plus. Here is interesting. So the tan, no, no, no. The cot is equal to cosine and sine. So that is ln 3. Negative sign over here. That's how it works now. Uh, and then it is derivative. Wait, sign's on the bottom. So actually I'm wrong. So it's plus ln 3 sine t. A stone is dropped in a well, and after so it's t total equal 2.47 seconds, right? That's when it got hurt. So in reality, that is t2 equal basically y divided by this is y distance, so delta y. If you go to delta, c, which is a sound, which is 342 meters per second. That's is needed there. So that's beautiful, right? That's T2. T1, on the other hand, has to be figured out by the length over here. And because we're going to start as something's going to be defined as 0, we can do YF over here. Now, where are we going to define the initial and final? We can define initial over here, but that will make it the final because that's what we're looking for now. If you define positive as this way, right? That's a beautiful way to do it, right? So we can do Y final as what we're looking for, Y initial. And Y initial, we can make it a 0 plus the velocity at Y initial is 0. Huh, this is a great idea, isn't it? Anyway, um, and then we have usually minus, but because gravity goes in the same direction as that, and this is another trick that you need to know, it's 4.9 t squared. It's a positive this time because you choose the direction, and that is a valuable lesson there. Okay, so t1, this is t1, equals square root of y1 divided by 4.9. Oh, okay, that's beautiful. So T1 plus T2 equal T total. So 2.47 must equal YF divided by C, right? Plus, what is it? Um, Square root of Y1 divided by 4.9. Okay, there we go. That's what to solve for. All right. In that sense, we can do 2.47 squared equal YF squared divided by C squared plus Y1, YF divided by 4.9. That sounds about right. Does it sound right to you? Then we can go. Let's go mode now. It's solving everything. And actually, we could probably just plug this into our calculator, but I'll be honest, I'm not sure if it's going to be correct. I don't trust it right now because I'll be honest, the calculator doesn't seem to sometimes get the right answer for this question, um, because of the rounding error or something. I don't know. But I'm gonna do this one more time before I go manual because I do want to see if this calculator can do it. But from experience, it looks like it can't because this is not my first time I'm doing this video. Uh, in this section at least. Yeah, okay, let's do it by hand. So with this sense, we figure out that actually the best way we could probably do it is basically just plug in the answer choices over here and see which one is the right answer. Remember that strategy a long time ago we did, where we just plug in over here because we can do A, B, and that, or we can just plug in over here like y, which is 2.4 divided by 342 plus square root of division of 2.4, 4.9. Now, because of this experience, I might not actually trust doing it by the calculator. It seems like the calculator has its own error system. I don't know what the error system is, but there's an error in the calculator. So don't trust the calculator all the time because I have been punned by it a few times. This is not my first time I'm recording this video, as I said. Um, And the reason is because when I use a calculator, I keep on getting 29, and apparently that's not the right answer when I double checked it later. And basically we're redoing this right now because of that. Yeah, it is 28. When you type it in the calculator, it's clear that it's 28 because that's the only one that works. It seems like there is a slight numerical error in the calculator if you do it if you auto solve it, which is pretty bad then. Okay, I was right. Every equation was right. Every math operation was right that I did. It's just that it didn't register correctly. So the answer equals 28 apparently. So C. So I'm starting to realize that calculator has a default problem. So trust your do a verification check or just don't use it. Either way, if it's a case like this where there's like two of them like very close, don't do it. It's not worth it. Headaches. All right. A motorcycle is traveling at 70 kilometers per hour where he sees a traffic light. Okay. In intersection 250 meters ahead, turn red. The light is red. The light's red cycle is 50 seconds. A motorcycle wants to enter the intersection without stopping just at the as the light turns green. What uniform deceleration of the vehicle will just put the motorcycles in the intersection when it turns green? So clearly, if I do 70 multiplied by 15, that is beyond. That's like a 1,000 something. So that's 250 about, right? The real question is what constant acceleration will make this go green. So we know the time, t equal 15. We are looking at s minus s equal x plus we have initial velocity and then t, and then we don't have we are trying to figure out the deceleration of this, so minus a t squared. In this case, we have everything else. We have the initial 2, that's going to be 0. We're going to have 250 over here. We're going to have minus what? The initial velocity minus 75, which is 75 kilometers per hour. Can you really? Why is all these FE questions in kilometers per hour, man? It's just annoying to actually just change back to this. Like it's so annoying now. I mean, 600. Enter. It's about 20.833 bar t, and then it is this, right? I moved it to the other side. So then it is multiplied by 2, and then it's square rooted equal negative a, which this is negative and then positive. So second square root of 2 parentheses 250. So be careful about your calculator. Some calculators are inferior to others, I guess, and you need to trust your own math skills too. Um, yeah, because some of the calculators are not great. Turns out after I said that. Anyways, where was this? 70. Did I do something wrong? Oh, I forgot divided by t square apparently. Dude, I got like 21. I was like, that is not right. Anyway, what is it? 15 square? We're about 15 square. Okay, I get. All right, let me redo this a little bit. What's VO? VO if wait, this is 70. That's what I got wrong. 70 multiplied division 1000 divided by 3600. It is in hours, so that's correct. That is about 19. Sorry about that. Oh, and I forgot to multiply by 15 there. I knew that was too small. So it's 290 1.66 bar. So second square root, okay, division, second square root, division, second square root of 2 parentheses 250 minus 291.66666. We'll just do 26 for that. Parentheses divided by 15 square, which equals a domain error. So I made a mistake here. Oh, wait. Hmm. Apparently the initial velocity is too big and causing a domain error. That shouldn't happen, right? So did I do something wrong? For 70, right? There's a 70 kilograms, right? 70, that's 19.44. Um, hmm. Okay. Okay. I must have made a mistake. Oh, wait a second. It's T. That's right. It shouldn't be positive and negative switching, right? Um, was it XO that's important? No, that shouldn't be it. That shouldn't be it. X is 0, XO is 0, which means the A. Oh, shit. I'm so sorry to all of you. Like, my brain. It's just negative because we're not solving for time. I don't know what the hell is going on with my brain right now. Okay, sorry. That was like not my finest moment move. Okay. Divided by what is this? 15 square? Okay, I get 0.37 03111. Okay, so C. Ah, that was beautiful. Okay. It's getting to 1, that's probably why. Anyways, next one is this one. If the vehicle decelerates at a constant zero point 0.5, what will the speed be when the line turns green? Well, you're gonna get a ticket, is what's gonna happen. Right? Or is it gonna be no? Oh, you're gonna be fine. You're gonna be fine. Never mind. You're gonna be fine. because that speed is less than is this a constant? When will its speed when will its speed when will its speed no, what will be its speed when its light turn green? Okay, so with that said, we can do something called V final equal VO plus A, in this case minus because it's decelerating T. Now here's the thing, we know V initial, but we have no idea about the V final time over here. So I know we do know the time. What are you talking about? We're given the time. So 70 minus 0 0.5, and we're gonna have to change this back to the appropriate unit. So 1000 divided by 3600 minus that multiplied by 15 equals what? 70 multiplied by division 1000 multiplied by 3600 minus 0 0.5 multiplied by 15 equals oh wow, that's really slow. It's 11.944 meters per second. But I have to change back to that, so it has to be 1000, no, 36,000 divided by 1000. So you're going to multiply this by division 3600 and then 1000 division. That equals about 43, so that's A. And that should be the answer if I am not wrong. And I'm just going to accept that's A and move on. Over here, okay. Refer to the following information. The position in 1011. The position in radians of a car traveling in a curve is described by this function time. What's the angular velocity at t equal 3? Um, Take a derivative of that. So I'm going to do it by hand because last time I got F by that. And I'm realizing that you will get F'd if you rely too much on the calculator because your calculator is not the best calculator is what I realized. And that's the calculator that you're allowed in the test. So rely on your instincts. And now you can put the, but you can do multiplication pretty well. I'm talking about doing the auto solvers. They are not that great, I realize. Minus 4. Okay, I get 11. So I'm accepting C is the answer. And we're moving on. Wait, we're moving on. Yeah, I got this being equal to 11. And that is what we're going to assume is correct. Next question here is get the angular solution. And again, I'm not trusting the calculator this time to do anything right now. It lost my trust earlier when it couldn't do anything properly. So it was 5. So 30 minus 4 equal 26 about. So that's D. All right. I'm talking about the polynomial stuff. I thought I found something amazing, and then it stripped me away because it was not that great. Anyway, the rotor of a steam turbine is rotating at, okay, we're doing those things again, huh? RPM. When the steam supply is suddenly cut off, the rotor decelerates at a constant rate and comes to a rest in 6 minutes. What's the angular deceleration of the whole thing? So 7200 is RPM, so 2 pi. Um, revolution, 1 revolution, 2 pi divided by 60. And then what you do is the rotor decelerates the constant rate and becomes 0 at that point. So what you need is A equal, I believe it is, well, what is this? V over time, right? So dd, right? So I forgot, what is this? Let me check. If I go over here, it should tell me actually, generally. It usually does. There's like the omega square or something for this one that makes life easier. If I can't find it, I will just do it. Um, I think it might be this one. It might be. Okay, I just can't find it. Hmm, that's interesting. How can I find it? It should be here somewhere. Okay, I'm doing it by hand. All right, looks like we're just gonna have to trust my instinct on this one. So this is what was the angular deceleration of the motor, which is basically alpha to figure out. And how we do it is basically V equal V, you remember this equation? OAT, there's a omega equal omega 0 minus alpha t version. It's the same equation, same thing. Now you put it in here and you should be done. So basically what you should do then is omega uh, final is 0 equal omega initial, which is 7200 pi over 60 minus alpha t, right? What is t all the time? T is 6 minutes. So 6 minutes multiplied by 1 minute equals 60 sec, right? So that's 3600 this time. So it is negative. So 72002 pi over 60 over 1 over 360. And that is basically it. What 7200 multiplied by 2 pi over 60 multiply 1 over 60, which is about 2.0 That is terribly something did not go right. Um yeah. I think it's probably let me check the did I do wrong on the no, let me check the original question. I can't find a mistake. The original question. Right here. The original question has a mistake where this is actually 5. I don't know why I made a mistake here. This was supposed to be in between 8, 5. It's supposed to be 5. So that's the mistake. It wasn't my fault. So over here, change it to 5, and you should get the answer you desire. Because I could not for the life of me find a mistake. And I realize it's not my fault. Okay, so it's 5 multiply that. So it is, what's 5 multiplied 60? That's 30. Yeah, that's a big difference. The 300, I mean. All right, I get, if I do this, 300 instead, which equals alpha, um, I get 2.513, which is B. Okay, yeah, remember that equation further later. A flywheel rate rotates at 7,200 RPM. When the power is suddenly cut off, the flywheel decelerates at a constant and it comes to rest 6 seconds later. Oh, 6 minutes later. Maybe the algorithm got confused because there's 6 minutes later here. How many revolutions does a fly make before comes to rest? Okay, so we have flywheel. So omega final minus equal omega initial plus constant. Actually, how many revolutions? So revolution is divided by 2 pi. So we should go look for what was it called again? Data, right? And then divide by 2 pi to get revolution. So instead of doing this, we can do data. Oh, by the way, if you're ever confused about why rotation is another aspect, rotation is data, right? Rotation is different than translational and vibrational. All three of them are different types of motion. A lot of people, and when you learn physics first, you learn the translational one, but you don't learn the other two properly, so you get confused often. But you just need to think of it as another mode of motion, basically. It's not the same mode of motion, which is why I'm always sick of the AP Physics 1. They teach it wrong, in my opinion. Okay, anyway, omega I, t and there's a minus 1/2 alpha t squared, right? And with that said, a flywheel, so we are dealing with 1200 RPM. Where does that go? That goes in here. So 7200 multiplied by what is it? 360. No, I'm getting tired, I guess. I don't know. It's called 2 pi over 60, right? And then, so I don't know what that is, but we could just plug it to our calculator right now. 7200 multiplied by divide 2 pi over 60, which equals something like 753.98. Does it make sense with the RPM we're given? It does. Okay, it kind of does actually. Minus, because it is a deceleration, 2.1 divided by 2 is 1.05. What is t squared? T squared is 60. 60 multiply that is 360 and then squared. And over here, I keep on forgetting the t. That's a thing to note then. I need to fix that. Um, we have 0 initially, so we just have to plug in here. I think the rotational question might be a plug and chug question because people genuinely do get confused by rotational motion. So, they might do this on purpose, you know, to make it so simpler. Okay, I get 215, which is about B. I'm gonna lock that in. 13 would be B, in my opinion. Yep, I hope I'm right. I don't think there's a mistake. So let's just plug in that, and you get data F basically. So that's how you do it. Okay, so we did that one. Next one. Delete the. Okay. All right. 14 and 16. A projectile has initial no okay initial velocity of a 110 meters per second and a launch angle of 20 horizontally. The surrounding terrain is level, no friction. What is the time of the projectile? So this is very simple. This is time, right? So I would do 0 equals 0 for y, and then you do plus v, which is 110, and we'll do sine of 20 t plus, it's going to be minus 4.9 t squared. And from last time I seen this, they fumbled my polysolve. I still don't really want to solve it by hand, so let's try polysolve again, even though it fumbled me last time. Maybe this time it won't. Anyways, excuse me. And then it is 110, clear, sine 20, parentheses, clear, 0, solve. I guess 0 and 7.67, which is B. I'm gonna trust that's correct because that sounds accurate. So most of the time it's correct. I think it's the weird ones that are off. Anyway, all right. What's the horizontal distance of the projectile? So we got 7.7 about as t. So we do basically do well, basically we do x final equals 0 plus 110 sine 20 multiplied by 7.7. Because there's no a equals 0 over here, we cancel that one out. And then we basically get this equation. Do we clear everything? 110 sine of 20 parentheses multiplied by 7.7 is 28. Did I make a mistake? No, I don't. Oh, no, yeah, I did. Sorry, my apologies. This is supposed to be cosine. Yeah, that would have been. Okay, 795, which is about C. So that is 800 about. So that is C. Yep. And we'll move on to the last question for the kinematics, I think. Okay, next is forces. So yes. All right. Projectile motion. Okay, it's the same question. What's the maximum elevation achieved? Well, that's 7.7 divided by 2, which is 3.85 seconds. And then you just plug it into, we just do YF equals 0 plus V initial, which is V, which is 110 sine, right? Theta, which is 20, T plus minus actually 4.9 T squared. And we know T equals that, so we just plug in T. So 110 sine 20 parentheses multiplied by this minus 4.9 multiplied by this squared equals about 72.21. So A is what I get. And